Okay, in this video, let's look at how to populate the ANOVA table using the LINEST results. Okay, we have developed the LINEST results in the previous video. Okay, so now let's look at the ANOVA table here. Okay, first is regression. Okay, so regression, the degrees of freedom is number of independent variables. So we know that there are 4, so we can just simply type in 4. But I like to use formulas and not type in numbers as much as I can. So here we can take these 4. Remember, that's b sub 0. So only the slope coefficients. So that will give us the degrees of freedom. And then sum of squares of regression is in row 5. Okay, and that is SSR. The first one is SSR. Okay, now residual error, degrees of freedom is here, degrees of freedom of SSE. So that's that. And SSE is in the 5th row, the second number. So that's our SSE. So now we have everything we need to complete the ANOVA table. Okay, so total is the sum of the regression value and the residual error value. So total sum of squares, total degrees of freedom is 154. Total sum of squares is the sum of these two. Okay, then mean square is sum of squares divided by degrees of freedom. Okay, you can copy. Now F value is MSR divided by MSE. Okay, and significance of F is the p value, and that is F dot dis dot RT. Okay, the F value and then the 2 degrees of freedoms, like that. Okay, so we'll talk about the significance of F or p value more little later. Let's make that into a percentage. Okay, so it's nearly 0. Now R squared, here is coefficient of determination. Coefficient of determination is SSR divided by SST. So that gives us the goodness of fit between Y and Y hat. Okay, we'll make that into a percentage also. Okay, now S is the square root of mean square error. We can compute that as the square root, or we can pick it up from the LINEST results. In row number 3, you see that, okay, which will be the same as square root of MSE. See, they both are the same. Now adjusted R squared, we'll talk more about adjusted R squared in a little bit. So here is adjusted R squared formula. You can use either one. Okay, this is a little involved and this is a lot easier to apply. Okay, so let's first compute the adjusted R squared. So 1 minus, okay, so here n minus 1. N minus 1 is the degrees of freedom for total sum of squares. So that's n minus 1 times S squared is mean square error divided by SST. Okay, so that gives us the adjusted R squared. Okay, now what happens in multiple regression is as you add more variables in, the residual error will always go down. So SSR will always increase, which means R squared will always increase. Okay, but that doesn't mean that the estimate of the variance S, or in other words MSE, will go down, because as you increase more variables, as SSE goes down, the degrees of freedom also will go down, because more degrees of freedom will go from 150 over to the regression side. So the numerator will go down, SSE will go down, but the denominator will also go down. So if the reduction in SSE is not compensated because of the reduction in the degrees of freedom in the denominator, your MSE may end up going up. So adding more variables, even though when you look at R squared, you'll feel as though you're improving your R squared, may turn out to be counterproductive because your MSE is not going to go down, MSE may go up. Whereas R squared is adjusted for that fact that you're losing a degree of freedom. So it takes into account the case that adding more variables has a cost, and is that cost low enough compared to the gain or benefit you derive by adding that one more variable. Okay, so that is your adjusted R squared.